Welcome to another video. I got 3 giant boards now. So I used to have 1, then I went to 2, and now I have 3 because I think it's time to go bigger, right? I have a problem here from the Stanford math tournament of 2011, and it is to evaluate this integral. Now, no matter how skillful you are, if you fail to see what they are making you see, you might just skip the problem and move on because this looks ridiculously difficult. But it turns out to be a very easy integral if only you can see the behavior of the sine function. Let's get into the video. Please leave a comment in the comment section about this whole setup. Maybe the board is too high, but this board is super long, so the whole thing is just long. Okay, let's try to do something with this function, considering the fact that if we substitute negative x for x, this is going to stay the same. This stays the same. This is the only thing that's going to change. Now, if you've observed the behavior of the sine function, whenever you substitute x for negative x, there is this beautiful symmetry about the origin. You always have that, where sine will always, what you have on the right is exactly what you have on the left. It's just that it's going to be negative, or it's going to be flipped this way. And that's the idea behind this integral. So what we're going to do is do a u-substitution where we're going to say let u be equal to negative x and see what it turns into. Okay? So let u be negative x. So that means that du equals negative dx. Or we can say negative du equals dx. Okay? And the boundary, if we modify this, we notice that u evaluated at negative pi will be equal to pi, and u evaluated at pi will be negative pi. So let's call this integral I, and let's call this j. Okay, so the new integral that we're going to be having when it's in terms of u, we're going to call it the integral. This time it's going to be going from pi to negative pi, right? And the integrand is going to be, we said x is going to be, how do we say it? So x is negative u. Oh, we should have done that. So x is negative u. Let's write that somewhere here. X equals negative u. So now our dx is now what? Dx is negative du. So we'll have times negative du. Okay, so this negative definitely can go all the way here, and when it gets here, it can flip this to back. So what you have is going to be the integrand from negative pi to pi. And here what you have will be just u squared over, and here we have 1 plus, sine negative u is negative sine u, so we're going to have it as negative sine u plus the square root of 1 plus sine squared u. Then we have du. Okay. Now the trick in this problem is to understand that whenever you're evaluating an integral, the name you call the variable does not matter. So we're going to say, okay, let's rename it and say it's x, because you'll get the same answer. You just need to integrate. And again, it's a definite integral. So what we have is going to be equal to, by renaming, negative pi to pi of you have x squared all over 1 minus sine x plus the square root of 1 plus sine squared x dx. This is the key to solving this integral, because what happens is, if this is j, and this is I, look, the boundaries are the same. The boundaries are the same. What if we add the two together? We just do I plus j will be equal to the integral, because they have the same boundaries, negative pi to pi of, now let's try to do the addition of these two things inside. This looks crazy. Okay, I'm going to try to do the addition. Let's just do some rough work here. So we're going to have x squared. So these are the two arguments of these two integrals. Whatever we get in the middle is what's going to be here. We're going to do our basic algebra. Wow, that's going to be complicated, but we have to do it because that's where the work is. Because your mind is not going to think it's going to resolve nicely. But let's look at this. This is, if you multiply this and you multiply this, you're going to end up with, this is going to be equal to x squared minus x squared sine x plus x squared square root of 1 plus sine squared x. And then you multiply here, you're going to have plus x squared. This times this is going to be plus x squared sine x. And then you're going to have plus x squared square root of 1 plus sine squared x. And the denominator is going to be, so this is going to multiply this. Let's start. This is going to be 1 minus sine x plus square root of 1 plus sine squared x. This multiplies this, you have minus sine squared x. No, minus sine x first. You got plus sine x minus sine squared x. And then you have plus sine x square root of 1 plus sine squared x. Okay, this is long. And then we go here, we have plus 1 plus sine squared x. Let's write it somewhere here. So I'm going to put it under, I'm going to put this multiplication here, plus square root of 1 plus sine squared x. Then this times this would be minus, oh, this will be here, minus sine x square root of 1 plus sine squared x. And then this times this is going to be just 1 plus sine squared x, because the square roots will disappear. So it's going to be 1 plus sine squared x. Okay, now just to simplify everything, these two will become 0 in the denominator. These will become 0 in the denominator. And that's it. Everything else stays. Oh, this sine x will get rid of this. So ultimately, in the denominator, we're going to have 1 plus 1 is 2, plus 2 of this. Whoa, that's all. It's going to be 2 plus 2 times square root of 1 plus sine squared x. That's what you have in the denominator. Okay, now let's go to the numerator and see what we got. Well, it looks like we're going to have x squared plus x squared, which is 2x squared. 2x squared. Then we have minus x squared sine x plus x squared sine x. These two cancel out. Okay. x squared times this. Oh, that's all that's left. So we have plus 2x squared square root of 1 plus sine squared x. Okay. Dx. That's what happens when you add I and j. Beautiful. Now, nicely, if we factor out x squared, maybe I should factor out x squared now so you can see that these two will cancel out and what you have left is just x squared. I don't need to write that. We just go here, negative pi, and you have pi. What you have left is just x squared dx. So the ultimate idea in this video is you recognizing that this function is exactly the same as this, not this function. This integral is exactly the same as this integral. They are just on opposite sides because of the symmetric nature of sine x when it's negative and when it's positive. Notice that everything else here stays the same except the sign. So the sign forces one to be on one side. And this happens no matter what function you attach to it, except some weird ones. Like the natural log function may just cause some weird shape because it doesn't go all the way to the left. And e to the x also. But every other regular function that will have both the positive and the negative parts will tend to just generate a symmetric function about the origin with sine. If sine is the only thing that changes. Okay, so here, the value of this integral and the value of this integral is exactly the same. So I plus j is the same thing as 2i. It's I plus I. That's the key to solving this. And now we've got an integral that we can easily evaluate. So now we go. We know that 2i is going to be equal to, if we integrate this, it's going to be x cubed over 3 evaluated from negative pi to pi. It's going to be pi cubed over 3 minus negative pi cubed over 3. That's going to be 2 pi cubed over 3 is 2i, which tells us that, maybe we can write it here, I is equal to pi cubed over 3. This is the value of the integral. I thought I was going to be using this part of the board. Never stop learning. Those who stop learning, stop living. Bye-bye.